this is Aurora with Supercharged Science. Hello, welcome everyone. We are doing a free homeschool science class in aviation, aeronautics, and flight. If you like this and you want more, you want to visit my website, which is www.superchargedscience.com/flight, F-L-I-G-H-T, superchargedscience.com/flight. I've actually created a free packet of homeschool lessons that you can do to get your kids crazy wild about science, and it doesn't even take any effort on your part. You simply hand it to your kids and they turn around and teach you science using everyday materials. So we are going to talk about flight today. For those of you who are joining me, welcome. And if you like this and you want more, remember, just go to www.superchargedscience.com/flight. Okay. So what are we going to talk about today? Actually, I want to show you a couple of different things. Not only am I going to give you a little mini lesson in what it's like to fly a real airplane, you're also going to get a hands-on look at some of the flying cars and vehicles that people had conceived of, as well as the one that's popular right now. And I'm just going to share some basic things in aeronautics. Now, this is actually taken from a much larger course that if you're part of my online eScience program, you'll, if you've actually purchased the aviation course, this is actually part of that. And so it's actually not a part of my online science class. This is one of those add-on classes because it's much more specialized. Okay, so let's get started. Now, as far as what we're going to be doing in class, all you need to do is you need just to sit back, relax. We're going to be together for maybe about 20 minutes. If you've got a question at any time during this presentation, I'm going to be sharing some slides with you, some videos. If you have any questions as we go along, you want to just type them in the comment box. In fact, you can type them in right now. If you just want to say hi, you can totally do that. If you have other questions and you want to share them with me, absolutely, about aviation or about flying, make sure you put those in there as well. Okay, so I am getting my computer ready to show you some slides because we have some really cool things that I want to share with you. Okay, so let me go ahead and switch to my computer monitor. Okay, here we go. So basically, for as long as we've been able to look up in the sky, which is like forever, people have always wanted to fly. And for about as long as we've had cars on the road and airplanes in the sky, people have wanted to put the two together to make flying cars. I actually just want to start by showing you what people have done over the years. So here's one. This is an Aerocar. This was an American roadable aircraft. It was designed and built by Moulton Taylor in 1949. 6 of these were built, but it never actually entered production because it didn't have enough funding. Isn't that cool? What about this one? Now, this one was named after the star Mizar in the night sky. This was built in the 1970s by the Advanced Vehicle Engineers, AVE. Now, the prototypes were made by connecting the rear portion of a Cessna Skymaster to a Ford Pinto. The 2 prototypes that were built never entered production. The car started to separate from the airframe during a test flight, and the pilot landed it in a farm field and then drove it back to the airport. So because of safety concerns, they grounded this particular project also. Now, the Jesse Dixon from Alabama invented a roadable helicopter. It uses a 40 horsepower air-cooled engine. There were foot pedals that actuated a hinged vane on the tail that you can see there, which used the downwashing air from the rotors to keep it straight during flight. And recently, 3 graduate students from MIT decided to give this type of idea a try, but instead of making a car that flies, because that's actually a really hard problem to solve, they actually decided to make an airplane that drives on the road, which is a different way of thinking about the same thing. So let me show you what they have done, and you might have seen this. This is the Terrafugia Transition. It's a 2-seat single-engine airplane that works just like a small. It works like a small airplane. You take off and land at a local airport, and then once you're on the ground, you can fold up the wings, drive it home, and park it in your garage. And these students found out that driving is a harder problem to solve than flying because driving has things like potholes and cobblestones, pedestrians, stray dogs, other drivers, and long list of rules and safety standards. And so this actually, after they designed it, the folks that make all the safety and regulations for our roads and highways decided, well, how do we classify this? And so they decided to put it under the category of SUV and light trucks as a multi-purpose passenger vehicle designed for occasional off-road use. So that's currently how it's categorized if you were to go out and use one of these on the roads. Now it uses unleaded automotive fuel, so you don't have to like lug your baggage around or take off your shoes or stand in a long line at security at the airport, because you just take everything with you. You don't even have to find a parking space of long-term parking at an airport. How cool is that? Okay, do you want to see that one actually in flight? I have a video and I want to show it to you. You ready? Okay, so let me grab my video here. Hang on just a second. Let's see. Hang on just a second. It's taking a minute. It's taking a long minute. Let's see. Oh, you know what? This is the second video I want to show you. I'm actually looking for the first one. Hang on just a second. Nothing ever works right when you first want to find it. Let me see if I can find it here. Hang on just a second. What do you think so far? Is this cool? So fun. Hang on. Let me see if I can find it. There we go. Okay. Here we go. I see it right here. Let me put it on my screen so you can see it. Still can't see it. Hang on. Oh, it's starting to play, but you can't see it, can you? Hang on. There it is. Okay, so here he is driving in it. Can you see it? Okay, so this is it when it's driving down the road and the wings are folded up. Okay, and it drives just like a very strange looking car, doesn't it? Let's see if he's actually going to get himself on a runway here. Kind of see it. Oh, he's pulling into a gas station. Okay. Here, let's get him at the airport. Okay, here we go. So now he actually has to drive in through the general aviation entrance, right? Because he has to drive onto the runway. Excuse me. And here he is, unfolding the wings. Isn't that cool? If you like this, let other people know that we're doing this class so they can join in also and ask any questions, since we're live now. And you can share this with them. Anybody you know that's interested in aviation, just let them know that we're doing this class. For those of you listening on the podcast, you probably want to go to the original Facebook Live. Okay, and there he goes. He's just taken off from the runway. The gear do not fold up, so he's going to stay like that, dragging it through the air. This is a picture from the cockpit. You can see what it looks like to actually fly, and it looks like he's coming in for a landing. Oh, no, looks like he's still taking off. Okay, and now he's flying his flying car. Okay. And let's see if we can get him. We can get him coming in for a landing here. Okay, it looks like he's thinking about it. See if we can fast forward him a little bit. Here we go. And here he is on short final. And he's coming in, touchdown. Kind of roll to a stop. And at one point, he's going to switch from the propeller to the internal combustion engine to start the wheels driving again. And he'll fold up his wings. Doesn't even have to get out. Okay, making sure that they fold up properly. And then he can simply drive to his destination. So how cool is that? So you do still have to be a pilot to drive and fly one of these things. You can't just, it's not just going to be open to everyone. So if you've got a kid who is really excited about learning how to fly an airplane, now you have even more reason because the commute would be much better, right? Okay, do you want to see what that company is designing next? Okay, so this one has already been on demonstration. They've done testing. They're working on bringing it into production. Let me show you the one that's currently on their design table right now. And this is a little bit different. So let me show you. This is just a computer simulation, because as I said, they haven't actually made the prototype of this one yet, but you might like to see what's coming next. Okay, so here we go. So this is the TFX. This is what they want to make after they're done with the propeller one. Okay, so it looks a little different, doesn't it? And this video is actually much shorter. Okay, so it drives along. It's a 4-seat hybrid with wings. So it's a hybrid vehicle. Okay, and this one doesn't actually need a runway, because watch what it's going to do. You just need a place large enough for it to extend its wings and do its thing. Now, even though it flies for you, you still would need to be a pilot in order to operate this vehicle. Take a look. So it's got a vertical takeoff and landing capability. The wheels finally fold up, becomes more aerodynamic, and off it goes. Okay, so notice that the rotors are now tilted forward. So it's a tilt rotor design. And they're estimating that they can design it to go about 500 miles. And down it goes. Okay, so this is their concept vehicle. And then it turns itself back into a car, safely stowing away the rotors. The mirrors pop out of nowhere. I don't know where those came from. And then you can drive it to wherever you like. So if that's not enough of a reason to become an engineer or a pilot, I mean, so there's so much coming in our future, and it's not enough just to give your kids like a textbook and a bunch of math problems and say, here, do this, and then you'll have a solid science foundation. You actually have to give your kids an experience and inspire them with stuff that is possible, give them ideas, because we need kids that can be innovators, can be leaders, can be the kind of kids that can look at problems and design and kind of come at them in new and interesting ways, because we're having problems that didn't even exist decades ago, right? So let's talk a little bit more about aviation. You like this so far? Okay, so let me share with you a couple more interesting things that I have prepared slides for. Okay, so if you were to sit in a cockpit of an airplane, do you want to know what it would look like? If you've never done it before, this is what you would see. I mean, overwhelmed yet? So how do you even start the thing, right? Well, there's a lot to learn if you want to become a pilot. All these cool knobs and instruments. And honestly, this is a really old cockpit. Now they look different. I picked an old one because they look much more complicated. But they're easier to kind of identify certain things. But this is a traditional cockpit of an older model airplane. So let's take it from the top. So if you want to fly, you're interested in aviation, right? So what is aviation? What is it? I mean, like, shout out your answer. What do you think aviation is? Okay, so aviation is the practical side of what we call aeronautics. And aeronautics is the art and science of flight. And so aviation is the design and building of airplanes, how to fly the thing from point A to point B. Aerodynamics is the motion of the air, the way it interacts with the aircraft, how it flows over the wing, and that sort of thing. Okay, now you tell me, is an aircraft the same thing as an airplane? Yes or no? What do you think? Yeah? What do you think? Well, aircraft is the one that's more general. And in order for something to be an airplane, it has to have all of these three things. It has to be, number one, heavier than air. It has to be propelled by an engine, and it has to use fixed aerodynamic surfaces to generate lift. The wings don't flap, they don't rotate. So every airplane is an aircraft, but not every aircraft is an airplane. You got that? Are gliders airplanes? Well, gliders are aircraft. They can't be airplanes though because there's no engine, right? That's what makes it a glider. How about the space shuttle? Is it an airplane? Nope, it doesn't carry engines for propulsion within the atmosphere. How about helicopters? No, their aerodynamic surfaces are not fixed, right? They rotate around. Okay, good. All right, let's go for a flight. You ready? Okay, so we're gonna hop in the cockpit of an airplane. We're gonna put on our headset, but we gotta make sure our airplane's ready to fly. Okay, so the first thing we're gonna do is we will call ATIS, and that's something that will tell us what the weather is, the most recent weather that they have, and they update it every hour, and you do that from inside the plane by tuning in one of your radios. And so you can actually hear it. You wanna hear what ATIS sounds like? Here, let me play a recording for you so you can kind of hear it. See how much of this actually makes sense. Okay, so let me play that and have it play through the speaker.
This is track number 67.
Salt Lake Airport Information Uniform, 2053 Zulu. Wind 180 at 9er. Visibility 10. Thunderstorm light rain. 2 clouds at 7,000 cumulonimbus, 13,000 scattered. Ceiling 20,000 broken. Temperature 30, 2.9er. Altimeter 2997. Remarks. AO2 thunderstorm began at 3:09.
All right, so that was really hard to understand, right? Because that one also was computer generated. So it's a little bit harder to understand than when a person does it. So let's see. Let me see if I can find one that is, let's see, airport. Here we go.
Only 7 left. There, left base, only 7 left.
Left base 407 left, and X52. Approach for
Lima. Daytona Beach International Approximation Lima, Tom 1753, Zulu observation. Wind 06016, gust 24, visibility 10, few clouds at 3,500. 7,500 scattered, 9,500 broken, temperature 27 dew point 18, altimeter 3018. Remarks? Rain.
So you see how that one was easier to understand when it was read by a human? Okay, so imagine you've got your weather now. Okay, so we're gonna look outside, so what is it? Is it clear? Is it calm? Was it, I think it said the knots were 10. That's the wind speed. So imagine it looks great for a flight. Now, if we're traveling to a new airport and not just buzzing around the area, we also have to file like a flight plan. Okay, so imagine I've already done that so we don't get bogged down with the details. Are you ready? Now what do we do, right? So now we've gotten our weather, we've made sure the airplane is okay to fly, we did our pre-flight, we walked around, make sure no screws were loose, everything looked good, we kicked the tires, we looked at the brakes, we did everything that we were supposed to do on our checklist. I mean, even pilots of 747s do these steps. Now we're actually going to take a look at our checklist at how we'd actually start up the plane. Okay, so when we start up the plane, we're going to go through a certain specific sequence. We're going to make sure we start it up and everything looks looks great. And then we're going to drive the airplane along the ground on a taxiway to get to the runway. Okay, so imagine we've done that. Ready? Vroom. Now we're holding short of the runway, and now we are going to get ready to take off. Okay, so we're going to begin to power up and begin our takeoff roll. And all that, you're going to hear some noise on the radio. Just ignore it and just listen to the pilot describing what he's doing. Okay, you ready? So here we go. Let's see here. Let me grab this video for you. You know what? That video is not playing either. Oh boy, this is all kinds of fun. Okay, so let's take a look. So imagine we've taken off. Okay, so imagine we've taken off. I'll get that video for in a second. We've taken off, right? Now what do? We have all these instruments that are like staring at us, right? So how do we deal with those? Well, take a look. In an older airplane, you're going to see instruments like this, okay? So I've labeled them for you here, and the one in the top left says airspeed. You see it? It's got a blue number 1 next to it. Okay, so this is like the speedometer in your car, only it has a lot more information on it. So this instrument shows you how fast you're going. The larger numbers on the dial are in miles per hour, and the tiny numbers close to the center, those are in knots. Now, 1 knot is just a little bit more than 1 mile an hour. It's like 1.5 miles an hour. So right now, just look at the bigger numbers. Okay, so what's our speed? Yeah, it's between 120 and 140, so it's about, we're going about 130 miles an hour. Okay, good. How high are we? Well, that's going to be our third instrument on the panel. The altimeter here reads like a clock, and the numbers that and like the big hand has to go all the way around before the little hand jumps to the next one. So the big numbers on the outside are in thousands of feet, so you have to add 3 zeros after your number. So right now we're nearly at 0, right? The little hand is at 0, but how high are we? Okay, so it's just past the 1. So that's 100 more, and so then the next tick is 100 more. Oh, I'm sorry. So each tick mark between here is, between the numbers is 20 feet. So this is showing us we're at 120 feet. That's how high above sea level the airplane is right now. So we're at 120. If it was here, it'd be 140. If it was here, it'd be 200. Okay. Okay, so are our wings straight and level? Well, this one is really important, especially if you get disoriented or if you're flying through clouds. We don't know, because you rely on your senses. If you rely on your senses, you're going to wind up upside down and in a total pretzel. And so you need an instrument that tells you if your wings are straight and level, and that's your artificial horizon. So you need to know if you're pitched up, you're pitched down, if your wings are, if you're making a turn to the left, a turn to the right. Okay, so the orange line are the wings of the airplane here, okay? And the blue sky and the white line dividing it, that's your horizon. And the little orange dot, that's the nose of your airplane. So take a look at this and tell me, take a look at the panel, what's going on with our airplane, okay? Are we climbing? Are we descending? Are we straight and level? If not, which way are we tipped? That's right, we're tilted, aren't we? What's the airplane doing? It's turning. Which way? Okay, it's turning to the right, and it's also climbing. Okay, good. Good job. Okay, so let's try to read another one. How fast are we going? Okay, find your airspeed indicator. This is a different picture now than the one I showed you before. Find your airspeed indicator. You see it? About how fast are we going? Okay, and I want you just to look at the top 3 here, and I want you to tell me our altitude and what the airplane is doing. Is it straight and level? Is it turning? Is it climbing? Just look at the top 3. Okay, we're going a little more than 100 knots, right? Or I'm sorry, 100 miles an hour. I'm going about 105 knots. Okay, and is the nose above or below the horizon? Which instrument tells you that? That's right, this one. The artificial horizon. See the little orange dot in the nose, how it's just a little below the horizon? So we're just descending, but just a little bit, and we're straight and level. Now, how high are we? Okay, gotta look at this guy. Okay, so it's a little bit past the 1, right? So that's, we got to add 3 zeros. That's 1,000 feet. Now the big hand is just past the 1, so we got to add another 100 feet, right? 1,100 and 2 tick marks is 2040. So we're at 1,140 feet above sea level. Cool. How does that look? How does that feel? Does that feel cool? Like you just read 3 instruments of an airplane. Okay, you want a little bit more? I have a couple more things I wanna talk you through. So we've been flying, right? Now it's time to land. Okay, so do you see numbers on the runway? You see anything? Okay, so runways are laid out according to the numbers on a compass. A compass is 360-degree circle where 0 is north and 90 degrees is east. So a runway's compass direction is that large number that's painted on the end of the runway. You just have to add an extra 0. Okay, so the runway with a marking of 14 is actually at 140 degrees. So what about this runway? What degree mark are we at? That's right, it's got a 26, so we add a 0, so it's 260. Okay, so it's over here. So is that north, south, east, or west? That's almost completely west. Cool. All right, so airplanes are built for specific purposes, right? Some of them are made for flying as high as they can go and while still being in the atmosphere. Others carry large loads and lots of people. Others get to their destinations really fast. Like the Concorde 2 is going to go from New York to London in just an hour. Some are like sports cars and they're highly maneuverable. Fighter aircraft are really highly maneuverable. The tilt rotor airplane here can take off like a helicopter and then rotate its engines forward so it flies like a regular propeller airplane. The Airbus Beluga carries sections of aircraft in it. Because different sections of airplanes are made in different parts of the world, and those airplane parts need to be shipped to one central place so they can all be assembled. So, so there's lots and lots of different areas for doing, for kids that are interested in either flying aircraft or designing aircraft, because aviation is such a huge, wide, varied field. So I want to pause here and just let you know that if you'd like this and you want more, don't forget to click. I've actually put together 5 lessons that you can download for free right now. There's a free aviation guidebook that I put together. Really simple. You want to go to www.superchargedscience.com/flight. superchargedscience.com/flight, and you can download that right now. And actually you can make all kinds of really cool things. You're going to make a flying machine here. I wrote it down up here. You're going to make a real plane out of balsa wood, which is great because one of the things that I do when I start teaching aviation is I have the kids design a plane and then we take it apart and find out what the parts are really for. Like, does the airplane need a body? Can it just be wings? What are the ailerons for? What's the elevator for? Do you really need a rudder? I actually had to fly an airplane with no rudder one time. That was very interesting. And so you'll be able to do that. You're also going to make slingshot rockets. You're going to make a different kind of rocket. You're going to make a rocket car. You're going to make like a lot of hands-on projects, because honestly, we use science and aviation to teach kids about the real world. A lot of curriculums out there, a lot of textbooks out there, and unfortunately a lot of educators, they do things backwards. They'll start with academics and they forget all about introducing the how and the why this is important, why you should care. And you know, have you ever had your kids ask, what do I gotta learn this for? And you don't have like a good answer for them? It's because you've missed that part about connecting what they're learning with why and how it's important. Unfortunately, a lot of math curriculum does this as well. They'll just have drill sheet after worksheet after memorization of equations and how to solve things. And kids are like, what do I got to learn this for? Linear algebra, who cares? You know, trigonometry, what do I got to use this for? And so if you teach math along with the science, aviation is a great example of this. You could do trigonometry when you talk about force vectors, when you talk about speed and acceleration, when you talk about the balances of forces on an airplane to make sure you're not too backloaded so the thing doesn't nose up when you're trying to take off and crash, right? So there's when you teach it in context, it's so much better because the kids, number one, learn it faster, and number two, it sticks because now they have context to it and it makes sense when they go through it. And then number three, kids are happier. And you know how easy it is to teach kids when they're happy versus when they really don't want to learn something? Yeah, it's like trying to push a freight train uphill, right? All by yourself. It's really hard. So if you can ignite that passion inside, that excitement, that spark that's inside that really just gets them excited about it, you don't have to spend a lot of energy and a lot of your resources, like your time and spending money on really expensive kits, because they already want to learn how to do this stuff. So I recommend getting our free guidebook. It's how to do real science, real math, real science using everyday materials, because you shouldn't have to spend a fortune in order to do real science. And there are videos on there. You can watch those. There's downloadable a booklet, a guidebook that you can use as well. All right, well, I hope this has been helpful. I hope you've enjoyed this. We're going to be doing more classes next week. We're doing a class in marine biology. You can go to superchargedscience.com and sign up for that as well. When you sign up, even if the date and time don't work out for you, just sign up anyway, because then you'll get on my personal email list to get personal invites to the next classes as they come around. We've got classes in biology and robotics and physics and geology coming up as well. So those will be offered, and we just have those just by email. So you get a personal invite to those as well. So I hope this has been helpful. I hope you've enjoyed the class. Oh, I think I forgot to see if any questions had come through. Let me look really quick if there are any questions. Oh, cool. So your brother-in-law is currently working on a flying taxi in Germany. Oh, awesome. Good job, Beth. You can actually watch this if you are, if you want the full course that this little segment was from, I should probably give you that website as well. It's www.superchargedscience.com/aviation. So superchargedscience.com/aviation will take you to the direct link where you can actually purchase the full course. And you can read all about it. It's actually, it's like a full, let me see if I can put up a picture of it here. It is a full course just in aviation that really covers the basics and really gets your kids like their feet wet in the whole aviation experience about what it's designed to do. You'll actually learn from real pilots on how to navigate using flight instruments, how propeller and jet engines work. You'll actually make your own flying machines, and you'll take your first flight lesson right from your own home. So if your kids love airplanes, gadgets, spaceships, and electronics, engines, radios, gyroscopes, everything that flies, this is a great area of science to get them interested in. Because I mentioned it's not enough just to get a kid, give a kid a textbook and say, hey, learn this by the end of the year and you'll be good to go. So there's so much more that needs to be covered today, including problem solving and innovation and creativity, design work. So there's so much more that you need to do with your kids. And if you feel like you don't have the time to teach it, or you don't have the background or the skill, then this is the program that you want to take a look at. So you can go to superchargedscience.com, and if you go /flight, you will get my free workbook that I've made in aviation. And if you go superchargedscience.com/aviation, that's that full course that actually covers a lot more in aviation. We just did a little bit, but so there'll be a lot more for you to view as well. All right, I hope this has been helpful. I hope you have a wonderful week with your kids, and I will see you folks next time. Take care, everybody.